Today we're going to talk about polynomial functions. First, we're going to talk about a monomial. Mono is a prefix that means one. So a monomial is one term. It can include numbers, variables, and exponents. For example, 3x to the fifth is a monomial. A monomial cannot include any addition or subtraction. If it's addition or subtraction, it becomes a polynomial. A polynomial, poly, is a prefix that means many. So really a polynomial is more than one term, or we can just write many terms. Now, why did I leave so much space under polynomial? There are two rules for polynomials, so I left enough room for you to write down what these two rules are. The first rule has to do with the coefficients. The coefficients must be real numbers. And exponents must be positive whole numbers. So the coefficients have to be real numbers. I want you to think about what are real numbers. Real numbers are pretty much anything. Real numbers can be positive, real numbers can be negative, real numbers can be fractions, decimals. You can even have square roots that are real numbers. The only thing that is not a real number is a square root of a negative number, or I. So the numbers in front of the variables can't be I or square roots of negative numbers. That's the only limitations for the coefficients. The exponents, I shouldn't have to write positive because technically the definition of whole number is positive integers. So the exponents have to be whole numbers, no decimals, no fractions, and no negatives. Standard form. A polynomial is written in standard form when the largest exponent term is first. And then the terms are written in descending order. So that means the term with the largest exponent is first, and then the term with the next largest exponent, and then the next largest exponent, and so on until you're out of terms. The leading coefficient is the number multiplied in front of the largest exponent term. Now, if your polynomial is written in standard form, the leading coefficient is the first number in the polynomial because the largest exponent term should be written first. So the number in front of the largest exponent term is the leading coefficient. And the one term that's not on here that you should add is degree. The degree is the largest exponent. The degree indicates how many factors of the variable exist in the function. So a 0-degree polynomial means that the largest exponent is 0. Do you know what anything raised to the 0 power is? 1. So 0 degree means there are no x's in the function. So here's an example of a 0-degree polynomial. -14. There's no x's. So you might want to write over on the side, no x. If you see a function that has no x's, it is a 0-degree polynomial, and we call that a constant polynomial because the value of the polynomial is constantly -14. A variable makes the value of the polynomial vary. So if there's no variable, the value doesn't vary, the value remains constant. That's why they call it a variable, because it makes things vary. A first-degree polynomial has x to the first, which is plain ordinary x. So 5x minus 7 is an example of a first-degree polynomial that is a linear polynomial. A second-degree polynomial. 2 means that there are 2 factors of x in here. So there's x times x, which is x squared. So if your largest exponent is 2, it is a second-degree polynomial, and we call that a quadratic function. If it is a third degree, your largest exponent is 3, and that is a cubic function. And 4, if your largest exponent is 4, we call that a quartic. Think of quarts like quart or quarter. There's 4 quarts in a gallon. There's 4 quarters in a basketball game. Quartic is 4. So 4th degree quartic, largest exponent is 4. In these examples, we are going to first determine whether each function is a polynomial. So think about the rules that we wrote up here. The coefficients must be real numbers and the exponents must be positive whole numbers. If it is a polynomial, we are going to write it in standard form and then state the degree, the type, and the leading coefficient. So A, is A a polynomial? Yes. The coefficients 5, -2, and 8 are definitely real numbers, and the exponents 1, 3, and 0 are positive whole numbers. So yes, it is a polynomial. Write it in standard form. We need to write the x to the third term first. Don't forget to attach that negative to that term. So -2x to the third plus 5x plus 8. That is written in standard form. Now we need to identify the degree, the type, and the leading coefficient. What is the degree of this function? 3. And a third degree means it's what type? Cubic. And the leading coefficient, the number in front of the term with the largest exponent, is -2. That's it. In B, I have heard yes and no. The correct answer is yes, it is a polynomial. -0.8 is a real number. Square root of 2 is a real number. It's not a pretty number, but it's a real number. The exponents 3 and 4 are positive whole numbers. So yes, it is a polynomial. Standard form, we would write the term that's to the fourth first. So square root of 2 times x to the fourth minus 0.8 x to the third minus 12. What is the degree? What is the type? And what is the leading coefficient? Notice I'm using LC for leading coefficient because I don't want to write out leading coefficient each time. All right, try C, D, and E on your own. We're going to skip F because I don't think you're going to need it. Remember that the f of x, g of x, h of x, k of x, whatever, those are just labels saying which function is which. C is not a polynomial. Why is it not a polynomial? Negative exponent. What about D? D is not a polynomial, and here's the best way to describe why. It has an unknown exponent. You can't have a variable as your exponent because you don't know what the variable equals. that variable could end up being an imaginary number, or a negative number, or a fraction, or a decimal. So because we don't know what the exponent is, it can't be a polynomial. E is a polynomial. Evaluate the polynomial functions for the given values of x. We are going to evaluate the function f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 when x equals 3. Parentheses are your friend. The first thing I'm going to write is f of 3. That is simply a label. It's a label that says I took the function f, I'm plugging 3 into that function. Everywhere that you see an x, you should put parentheses directly around it. So 2 parentheses 3, close your parentheses to the fourth, minus 8 parentheses 3, close your parentheses squared, plus 5 parentheses 3, minus 7. You should plug this exactly like that into your calculator. Now the TI-84s, there's one kind of weird thing about them. When you do 2 times 3 raised to the fourth, do you guys know where the exponent key is? It's the little caret that's directly above the division symbol. Now, something kind of weird happens when you go up into that exponent. Your cursor stays in the exponent, and unless you tell that cursor to come down out of the exponent, the rest of what you type is going to be in the exponent, and that's bad. So push the right arrow to move down out of the exponent, and then continue with, oops, I forgot my minus sign, minus 8 parentheses 3, close your parentheses squared, plus 5 parentheses 3, minus 7. If you entered this into your calculator correctly, you should get 98. Here's how I'd like you to write your answer. F of 3 equals 98. This tells whoever is looking at your math that you took the function f, you plugged 3 into it, and you got 98 as your answer. The parentheses are even more important on example B because we are going to plug in a negative number. And in order for your calculator to do this correctly, you need parentheses around that negative. So g of negative 4 equals negative parentheses negative 4, close your parentheses to the third, plus 3 parentheses negative 4, close your parentheses squared, plus 9. Enter that into your calculator. And if you watch the video later, it actually shows, like it highlights every button that I push on that calculator. G of negative 4 is 121. Your assignment is on page 192. Yeah, wow. Your assignment is on page 162. Numbers 3 through 6 and 11 through 14.